Hi everyone, welcome to Java Techie. When building microservices, choosing the right architecture is super important to keep things flexible and loosely coupled between components, right? So today we are going to talk about one of the most powerful and flexible design pattern, that is hexagonal architecture, and it is also known as the ports and adapter design pattern. Now, don't worry, it's not about drawing hexagons in your code, it's all about structuring your application in a way that's modular, testable, and really easy to extend when your business needs any change. That's out of the box, isn't it? In this video, I will explain it using simple real world analogies, walk you through a hands on example, and show you how to build it step by step with Spring Boot. So stick around. By the end of this video, you will get a clear idea of what hexagonal architecture is, why it matters, and how to use it in real time projects. Okay? Alright. So without any further delay, let's get started. So first, let's understand the problem without hexagonal architecture, then we'll see how it solved that problem. This way, you'll get a clear picture instead of just trying to remember it. Okay? Now, let's say you are building a food order system. A user place an order via REST API, the controller receive the request and pass it to the service, then your service call your database to save that order object. This is generic and simple flow which works perfectly fine. And we can call it as a three-tier architecture where you have presentation layer, service layer, and your database layer. Now what is the problem here? Now think about, what if in future your business grow and you want to accept order not only via REST but also from Kafka. Now in that case, since you have two sources to get the inputs, your service class now has to handle logic something like, if request coming from Kafka, then execute this flow, or if it is coming through REST API, execute some different flow. Now think about another scenario. Tomorrow you want to change your database. Now currently you are using MySQL, but tomorrow you want to change it to the MongoDB. Or let's say you want to store order not only in MySQL but also in MongoDB for analytics. Then it becomes hard because each layer directly depends on the other one. So to overcome this type of problem, hexagonal architecture comes into picture, which helps to maintain loose coupling between services with port and adapter patterns. Okay? Well, first let's try to understand what hexagonal architecture really means, and to make it super simple, let me explain it with a real world example. Now imagine you have a hexagon shaped power socket with multiple ports. You can use it to operate different devices. Let's say you want to charge your mobile. To do that, you need a mobile charger or adapter that you can simply plug into one of the socket's port. Once it connected, the electricity flow and your phone starts charging. Simple, right? Now after a while, you want to charge your laptop. What do you do? Just unplug the mobile charger and plug in your laptop charger, or maybe use another port in the same socket. Either way will work because the socket remain the same and electricity keep flowing regardless of what device you connected, right? Now you might be thinking, hey, why is this guy giving me a tutorial on how to use a socket? But hold on, let me now connect this analogy to a real software use case, and you will start to see a big picture of hexagonal architecture. Let's take a simple example of food ordering system, and right now we are just focusing on a single use case, that is place order. Now if you understand the ports and adapter pattern properly, just imagine this. You have a power socket which is a central hub that supply the electricity. Similarly, in our application, that central hub is nothing your order service, where all the core business logic resides. Now, how do you connect a device to the socket? Using adapter. Simple, right? Similar way, in our application, request can come from various sources like REST API, Kafka, or command line interface. So these are your input adapters. They plug into your system and pass the request into the core logic, that is nothing your order service. Now think about the destination. Once the socket supply electricity by the adapter, where does the output go? To your mobile or to laptop, which is your final device. Similarly, once your order controller, which is nothing your input adapters, talk to the order service, it might need to store the result either in database, or it can write to a file, or it can publish to the Kafka. So these are your output adapters. Now, here is the interesting part. Every adapter connect to the socket using a specific port, right? Not all the ports are the same. Some are meant for charging the device, some are for running your TV, and other for your washing machine or for any other device. Similarly, in our application, the controller connect to the service using specific ports, like one input port for place an order, another for cancel the order or tracking the order. These are called input ports because they define what the application can do. They basically expose the use case to the outside world. And finally, once the adapter starts flowing electricity through a cable to your device, that cable is nothing your output port in the application. It could be either JPA cable or Mongo cable or even Kafka cable. Basically define what the service needs, or in other words, the dependency of your order service. Okay. So that's how the entire hexagonal architecture fits in. Your core logic is protected in the center, and all the external system connect through well defined ports and adapters. If you remember, in the beginning, we talked about the tight coupling problem in traditional three-tier architecture, right? Now let's see how this hexagonal architecture address those problems. Now suppose today you are accepting request through a REST API, but tomorrow you decide to support Kafka event. Then guess what? You don't need to rewrite your business logic. Just plug in a new Kafka adapter, then you are good to go. Now take another scenario. Let's say today you are using JPA with a relational database, but in future you want to switch to MongoDB. No worries, you can simply unplug the JPA adapter and plug in Mongo adapter without touching any of your core logic or service classes. So that's the power of hexagonal architecture. It makes your application modular, pluggable, and ready for change without touching your core logic. Okay, don't worry, we'll understand more about this hexagonal architecture once we start implementing it. Okay, but before that, I want you guys to remember this term. Without knowing this term, it's difficult to understand hexagonal architecture once we start coding it. Now just imagine this socket, adapter, input adapter, output adapter, those kind of concept. So to make it simple, what I can do, we can compare all the term to the real time implementation. Okay. Now what we understand, we have the adapter input, which is nothing this particular socket, not socket, this particular adapter. Then port input is nothing the port present in your socket. Then core logic is nothing supply the power. Then port output is nothing your charging cable. Then adapter output is nothing your mobile device or database. Now try to connect this term to the real world implementation. Now in application, what will be my input adapter, how the request is coming to my application using either REST or Kafka, or you can say controller or Kafka listener, right? Now what is the port input, what use case you want to perform. I want to do place order use case. You can also define multiple input port for place order, track order, and cancel order. Now, what is next? Core logic. core logic is nothing your order service. Next, output port. Now how you want to send your output from the adapter. I mean, what is the medium? Like charging cable, what is the medium? Now for me, the medium is repository, JPA repository or Mongo repo or anything, any external source you can define. Okay. Now, what is the adapter output? The final destination where the output will go. In our case, our final destination is database or file system or any cloud. Okay. If you remember this particular flow, then you are good to go with the hexagonal architecture, and I can guarantee that while writing the code you can easily relate this term. Okay, so make sure keep this thing in mind so that it will be easy for you to understand the code. Okay, now I don't think I need to give any theoretical definition about hexagonal architecture. Rather, you just read this definition and let me know if you have any doubts after understand this flow with a simple example. Pretty cool, right? So I hope now it's crystal clear for you and you are confident enough to respond if someone asks you about hexagonal architecture. If yes, then let's take this same use case and see it in action. Now let's jump into our IntelliJ idea and get started with the coding part. So before we start writing the code, first you need to understand how you can define your project structure so that you can segregate your core logic with the secondary logic. Okay, for that, if you see this high level diagram of hexagonal architecture, you have the REST adapter and gRPC adapter, which is nothing your input adapter, will talk to your input port, and input port will connect to your business core logic. Then the business core logic will send the output through the output port, and then it will either goes to the database or it will send the notification or it will send the Kafka event through the output adapter, right? This is the simple flow. So if you observe carefully, the center part is nothing your domain section. Okay, when I'm saying domain, it is constant. Your business core logic is same, your input and output port is also same. That is not going to change anymore in future. Okay, but what things will be changed? Your left part and right part. Left part is nothing your input adapter, which is also called as a driving side. How the input is coming to your core logic, that is what called driving side. Similarly, right part is nothing your output adapter, which is considered as a driven side. How the output goes from your service. Okay, that is how there are two terms, driving side and driven side. The center part will be domain section where you will keep all your business logic, input port, output port, everything. Then you can define an adapter package where you can keep your input adapter, different type of input adapter, output adapter and its type. Okay, so this is how you need to create a project structure. So now let's create the package structure by keeping this picture in mind. Okay, so see, basically writing the code is not a big deal. How you are segregating your modules and component, how you are defining your project structure, that is the more important in hexagonal architecture. Okay, so what I can do, since you understand there will be two different section or two different module we need to define. Domain module, which will contains all the non-spring component. When I'm saying non-spring component, if you understand this particular flow, which is nothing your business logic and input port, output port, and then if you have any DTO or anything wrapper class, you can keep them in a this particular domain section. Okay, next is your adapter. Adapter is nothing your input and output source to your application, right? The left part and the right part. So those things you can keep inside your adapter. Next, config module. Since all the classes what we have defined inside the domain is non-spring component, to inject them or to play with the spring framework, I am going with the config. Okay, so it's not mandatory that I will always use spring framework. So that is the reason I keep plain Java code in domain logic. I can go with the different framework and I can keep their specific configuration in the config folder, right? So to make it more simple, what I can do, let me create the package structure here itself. Okay, so what we understand, what is the key things we can keep inside the domain? Core logic, which is nothing your service, and port. Okay, so let me define that, or I'll just name it service. Then what else? I'll define port, right? Now, apart from that, if you have any DTO class, you can keep inside the domain. So I'll name it DTO. Fine. Now, your service is nothing your core logic. Now, port can again divide into two type. It could be a input port and it could be a output port, right? So I can define, correct. Now, what can be part of the input port? Your use case, what you want to expose or what action you want to do. So in our order service, what action we want to do? We want to place the order, we want to track the order, we want to cancel the order. So those three use case I can keep inside input port package. Okay, so let me quickly define these three use case. Now what could be part of your output port? How you want your results to transport to the output adapter. I can go for the repository port. I can also send through notification. It could be email or SMS, or I can also go with the messaging output port. Okay, it is up to you how you want your output to go from your core logic. So you can add couple of section here. Let's say repository port. Which repository I don't know. We just define the repository port. So which type of repository port, that implementation you can define in the adapter. Okay. Now here let's say it could be a notification port or it could be a messaging port. Fine. Now if you have any DTO, you can define inside this DTO package, or any wrapper class, any util class, you can define inside this. Let's say food order. That is interesting, right? So the domain part always contains your core logic. See, the reason I am keep repeating this package structure, because this is what the top part to understand as part of the hexagonal architecture. So writing the place order use case is not a big deal. You can do it within a minute. But defining the package structure is little bit tricky in hexagonal architecture, and that you can only relate if you understand this particular flow. Fine. Now let's define the adapter package structure. Now in the adapter package structure, what you can define, how the request is coming to your application and how it is going from your application. So to and from external source to your application can define inside the adapter. Now let me define the input and output. It could be a REST controller, or it could be a Kafka consumer, or it could be a command line interface or gRPC. Next, in output adapter, how your result can go from your application, or where you want to store, or how you want to operate with the result. That is what the output adapter. Basically, it's just the destination of your outcome from your core logic, which is order service. So the output could be either database, or when I am saying database, let's specify the implementation. It could be JPA, or it can be MongoDB, or it can be a file system, or even the output I can send to another Kafka message, Kafka events, anything you can define. Apart from this input adapter and output adapter, all the external source which connect to your core logic, like your entity, like if you have any mapper class to convert DTO to entity or entity to DTO, or anything else which connect externally to your system, can be part of your adapter package. Okay, so this is how you need to define the package structure while creating any project following with hexagonal architecture. Okay, now since you have the clear picture of project structure and also clear picture of hexagonal architecture. Now let's start create a new project. Okay, so to save our time, already I created a project structure the way we just discussed different folder or different package structure. If you observe package name or the application name food order system, then we have domain adapter and config. Inside domain we have the service package, we have the port. Again, port is categorized as input port and output port, then DTO class. Similarly, in adapter we have input adapter, it could be Kafka or REST, and we have output adapter where you can define your repository port, you can define your notification port, and I just kept entity and repository. Okay, same thing what we have discussed here, I just replicate that by creating a package structure. Now let's do one thing. Let's follow this architecture and create each and every classes step by step. Now first step, how request is coming to your application using input adapter, that is REST adapter, right? So first let me create a REST adapter class. Now basically I just need to create a new controller class. I'll name it order controller. This is my input adapter. Now, how this adapter can connect to the business logic through input port, right? So let me create different input port. Input port is nothing, your use case, what you want to expose to the outside or what action you want to do. Okay, so I'll go to the port section. Port section you will find inside the domain. Okay, go to the input port. Now let me create an interface. Place order use case. Similarly, let's create another use case, name it track order use case. So let's keep these two for simplicity. Let's not make the code complex. We'll go with these two different use case, place order use case and track order use case. Now if you observe here, I have defined this place order and track order use case as an interface, because always remember ports are just interface, whether it is input or output, these are just interface. They define the contract but not the implementation. The implementation you will found inside adapter. Okay, so let me define the contract for place order. Pass the input food order. Now to track the order. Okay, now if you observe here, we have defined the REST controller. Now we have the input port. So to connect to the business logic, my REST controller needs to call the input port. Okay, that is the port in the socket and this is the adapter. So how I can use that? For that, go to your controller class. Then in controller, simply inject these two input port. Once you define these two input port, now you have the contract, what task you want to do as part of this adapter. Hey, I want to place the order, I want to track the order. That is the two business I want to expose to the outside of world using this input port as a use case. Now simply just define your endpoint. Just change it to string because we just want to display the status, right? So my adapter connect to the input port now. So here also I will define one root URL. All good. Now go to the flow again. Your adapter connect to the input port. Now this input port needs to connect to the core service, that is your order service. Now how it can connect? Let's define that. First, go to the package, go to the domain, then inside service, create a new Java class, name it order service. Don't define any annotation because that is what we understand, right? The things will keep inside the domain, the middle section, which we don't want to define any technology specific class, okay, any framework specific class. So you can define, that's not a big deal, but let's keep it separate, keep it in a center to just hold your core logic or business logic. Okay, now what I can do, how this order service which is nothing, your core will connect to the input port. For that, what you can do in core service, just implements from your use case, that is your input port, right? Place order use case, also track order use case. Then you just simply override these two methods. Now remember the flow. Once your adapter call the place order dot place order methods. Okay, so see, this is the input port. Now once your controller call that method, this is the interface, and you can find the implementation here, right? This particular method will execute. So first I will set the order status as a placed. Then what you want to do, similarly here, to track the order, you can do the db call and you can fetch it. It could be a db call or it can be anything else that you can get to know from where, from the output port, this section. The REST adapter, input port and business core logic we already defined. Now how input come to this point, we know that. How the output will go from this service to right section, that is what something we need to design. Okay, so for that, what you can do, if you understand here, your business core needs to depends on output port. Output port is nothing the dependency for your order service. How you want to play with the order input what you received. Okay, that is how you can define inside the output port. Now go to the package structure. Now go inside domain. Here you can see the output section, right? In output port, just create another interface to just define what you want to do. Okay, I mean what you want, how you want your flow or the output flow from your service to the destination. I want to use the repository database concept. Okay, so let me define that. Now if you want, you can also define notification, order notification port. I'm not going to implement any SMS or email stuff, but you can segregate that. Okay, so that is the reason I'm showing how you can define that. You can define another interface. Now go to the order repository port. Here, what is the contract? Hey, the contract is to place the order. So I'll just define save order. Also, what is the next contract? The next contract is void or string track order or find order by ID. Okay, this is what my output port. You can again define the notification port. Let's skip that for now. Now you have your output port, which is nothing the interface. You can define its implementation in your adapter, output adapter. Okay, so if you observe the flow again, we have defined the output port. Now that output port needs to connect to whom? The database adapter to complete the flow, right? So let's create the database adapter. Go to your domain, go to your output, then just define a class, Java class. You can name it JPA order repository since I am working with JPA specification, or you can define Mongo, or you can define any file system. That is up to you. I am just keeping the thing simple, so I have created a JPA order repository. Let's create it. Now this needs to implements from whom? From your, if you observe the flow again. So that is the reason I am saying keep this picture in mind and start creating the class. Otherwise you will get confusion. Okay, this is what I created, then where to inject or how the flow can go. Now we have the output port and adapter. This adapter will implement the output port, right? Go to the code. Now what is the port we have? That is order repository port. Just implement that. Override the methods. Now you can annotate this at the red repository. Fine. Now this is the place I can use my DB operation. How can I do the DB operation? We have already created a repository package with Spring Data JPA implementation. You can go for Mongo, you can go any implementation. Okay, this is the library or this is the template we do follow for Spring Data JPA. Now I can directly inject this. Now here simply I can do repository dot save. What it is expecting me to save? it is expecting me to pass the order entity. If you observe the repo, we have created one entity class that I need to pass. But what is the input I am getting from my service? See here. This is the business core, which is nothing your order service. What output your order service is giving? A DTO model. Now you need to convert that DTO to entity to store it into the database adapter, right? So for that, what you can do, you create a separate package in the adapter output called mapper and write that mapping logic. But I will simply create those classes here only. I mean, I will just define a methods map to entity, map to domain, okay, or DTO, anything you can define. Now I can define map to entity, give the food order object. This will save to my DB. Now while fetching, what I can do? First I need to get the order entity object from the DB by this ID. Then I need to return the status by converting it to the domain. Correct? So I'll just simply write this. Get the object from the DB, then convert it to the domain and return it back. What it is saying? Require type string. Okay. So just get the status and return it back, because that is what the methods we have defined in our interface order repository port. All good, right? We have this output adapter. Now what next? Now go to the flow. We have created the output port and we made the connection to the database adapter. Now this output port can talk to my service, or my order service can only talk to the output port to flow the result to the destination. Okay, so for that, what I can do, I'll go to my order service, then I'll just inject private order repository port, right? Define the constructor. Now just use this order repository port to perform your action. So I can simply do port dot save order, give the order object, then track the order, get it from order repository port dot find by id. Okay, now observe one thing, your order service don't care how your order is going to save, whether it is going through the DB or it is going through the Kafka. He don't know anything, because you are not injecting your destination or output adapter directly. What you are injecting to your core service, that is output port. Now how your output will execute, that is completely abstract to this order service, right? See here, order repository port dot save order. What this port doing, he is completely not aware about it. That is what you can see, right? The business core will talk to the output port. Now how output port will handle that result what I return, this business core don't know anything. This is how the simple way you can segregate your core logic to the external system. Now tomorrow you don't want this database adapter, right? Just exclude this output port and plug a different adapter what you want to play. Similarly, you don't want today REST to play, you want Kafka. You can simply unplug this input adapter and plug the Kafka adapter. The blue center part is remain same. There is no change on it. Only the external system, input port, output port and adapter, you are just keep changing for your different use case. Okay. Now let's go to the code. We are all good. Now what we can do, since this order service is not Spring specific class, but I want this to be registered as a bean because I want to use the Spring framework. What I can do, I will go to the config. I already created the config class. This will be my order service, and order service connect to the order repository port, right? So I'll just do this dependency injection here. Now Spring will create the bean of this class. This class will connect to the output port. Output port has the implementation in adapter. Can you see here? Now this is having the Spring specific things. The things will be executed here. So we are good to test our application now. But for you to understand it correctly, what I can do, I will add the log statement, or I will just add the sysout statement to validate the flow whether what you understand is correct or not. Okay, first request will come to the input adapter, right? So I'll just add some sysout statement here. Next, request will go to the input port, correct? But it is the interface. Let's go to its implementation class. Is nothing our core logic. So what I can do here, I will simply define core logic executed with input port. Now what next? Now once input port execute your core logic, I mean the request come through the input port, then it will goes to the output port. So this is what our output port. But again, output port is also an interface. So let's go to its implementation, which is nothing your output adapter. Okay. So I'll just add a sysout here. Simple thing guys. If you check the flow again, input port and output port, these are just interface. So the implementation for input port will be your adapter, and implementation for your output port is nothing your output adapter. Okay, so that is the reason I have just added the log statement for adapter and core logic. All good. Now what I can do, let me go to the resource 9191. Let's change it to, okay, let it be 9191. Now let me start the application. So application started on port 9191. Now let's go to the browser and I will open Swagger. You will find two methods: post the order, I mean place the order, track your order based on the ID. Now let's execute the post. Before that, let me clear the console. Order ID I will give something, some random string. Customer name, let's say Basant. Restaurant name something ABC. Item again XYZ. Give any meaningful value. Status will be auto set. Remove it. Now let me send the request. Order placed. Now if you see the flow, core executed with input port. But where is the input adapter? This is not in a sequence. Okay, so the mistake what I have did. So I kept the statement after it execute my port. Okay, so keep it before. That is the reason you are getting confused. But for this track order, you will get the correct result, I believe, because you have defined it before. Let's test it. Okay, so this is working, right? We got the response here. Can you see the output? With the hexagonal architecture, we are able to segregate all the logic, but system is still working. There is no failure. Now let's check the other one. What is the order ID it created? Let me check the DV. So if you observe the same order ID, we are just persisting it. Just use the same order ID and try to face the second API. Again, clear the console first. Send the request. You got the status order placed. Now if you see the flow, yeah, can you see here? First input adapter executed, then core logic execute with the input port, then it do your DV connection and all. You can see the output adapter executed with output port. The flow, what you understand, is absolutely correct, right? As per the hexagonal architecture, the things what we execute, we got the correct output, right? So again I repeat, understand the flow, how you can segregate the things, how you can segregate the primary and secondary logic. That is what the core principle of hexagonal architecture. Now you can say we achieve the modular in our application. Now what about loose coupling? How can I achieve the loose coupling using hexagonal architecture? Now currently my all the request coming to my application through REST adapter or REST controller. In future I want the request to come from Kafka as well. Okay, then in that case what I need to do? I don't need to change anything on my core logic. Rather, I just need to plug a another adapter called Kafka adapter. All the things will remain same. I only need to change my input adapter. Like I have REST adapter, gRPC adapter. Similarly, I can add another Kafka adapter to any of the existing port, or I can add to the new port. Now let's try to understand this loose coupling scenario in action. Now Kafka is nothing my input adapter, right? Go to the adapter. Already I created a package called Kafka. Now what you can do, create a class called order Kafka consumer. Okay, you can annotate this at the rate component, and you can have the Kafka setup. Currently I am just writing the pseudo code. I don't want to integrate any Kafka related stuff here. Only I am just giving the template how we can inject the new adapter. Okay, so what you can do here, this is the input adapter. If you understand, this is the input adapter, new adapter, which is Kafka adapter. He needs to connect to the input port, and in my input port we have two different use case, place order and track order. So he will use both of the port. Okay, so I'll just define, then just define a method public, just change it to, then just annotate here at the rate Kafka listener. It don't allow me because I don't have dependency for Kafka. You can define your topic and everything. Okay, now what is the changes you have done here to just play with the Kafka? In the existing flow I just added another adapter. That is what the simple change I need to do. Then I can reuse the same code, right? Place order use case, which is nothing my port. The same port will connect to my core logic. Core logic will connect to the output port and then output adapter. Only changes, you need to onboard a new adapter. That is what the simple things you need to do. You no need to do the change in different place. Only you did the changes on the input adapter. Okay. Now similarly, let's say you want to discard any of the output adapter. Let's say you don't want to use the MySQL or JPA adapter. Rather you want to use the anything, MongoDB or Redis, any different adapter you want to use. So for that what you can do, go to your code, go to your output adapter. We have defined this JPA order repository, right? Similarly, you can create another adapter. Then you can simply implement it from, what is your adapter, I mean the output port, order repository port, right? Override the method, then simply inject your Mongo repository. Now start using your logic using this Mongo repo. So if you observe, injecting new things or extending something on the existing flow is dead easy. Just add a new class. All the core logic will remain same as it is. Okay. So this is what the power of hexagonal architecture. You can maintain modularity and you can achieve the loose coupling. So just try to implement the actual Kafka logic and Mongo logic to complete this example. This is all about your hexagonal architecture. So I hope you get the clear picture about hexagonal architecture. So just give a try, and if you found it fit to your project, just try to implement it, and do let me know in a comment section if you have any doubts.